Hi everyone, this is Sumanth. In this video, we will just try to understand what is a normal distribution. So this is an important topic in statistics as well as the data science. So we will just try to understand what is normal distribution, and also we will just try to understand like what's the use of it. So yeah, make sure to watch this video till the end, and also for more such kind of videos, make sure to subscribe to the channel and also like this video. So with that, let's start this. So what is normal distribution, right? So what is mean by distribution first? Distribution means it's a kind of plotting the data, right? For example, let's take age variable. So if you just plot this age in the form of histogram, right? If you just plot this in the form of histogram, this is distribution, right? Like plotting the data in the form of, so this is called distribution, right? Now, what is normal distribution? So normal distribution in the sense, the distribution which you are just plotting is normal, right? So what is normal? What exactly is normal? So normal in the sense, it should be in the form of bell curve. It should, the distribution should be in the form of bell curve, right? So this is the distribution. For example, let's take, this is the age variable and we just plotted the distribution here. So now if the data which you just plotted here is in the form of bell curve, right? So if it is in the form of bell curve, so then that distribution is called as normal distribution, right? You can see it's in the form of bell shape, right? So that's why it's called as bell curve. So yeah, if you just take a data, any kind of data, and if you just plot that data, and if that data, if that distribution is in the form of bell shape, then that's called as normal distribution. So if this is the distribution, then the center value is generally it's a mean, right? So this is mean. And if you just move one step towards right, so this is mu plus sigma. So this is one standard deviation right to the mean. And similarly, this is mu minus sigma, right? One standard deviation left to the mean. Similarly, we will have, so we used to have mu minus 2 sigma, mu and mu plus 2 sigma, right? So mu is mean and sigma is standard deviation. Now what's the use of it? Like we just understood the data is normal, right? We just understood the data is, so if our data is normal, if we just plot the normal distribution, what's the use of it, right? So that's where the empirical formula comes. So yeah, we will just try to understand the empirical formula. So yeah, you can see I've just drawn this normal distribution again here. And so what's this empirical formula? So if your data is normal, for example, let's say you just have certain data and if you just found that if your data is normal. Now, so the empirical formula has 3 rules, right? The rule number 1 is 68% of the data falls under first standard deviation, right? So what's the meaning of that? So here you can see we just have this mu plus sigma and mu minus sigma, right? So if your data is normal, then 68% of your entire data will fall under this. So it will just try to fall between this, right? Between this mu plus sigma and mu minus sigma. That is the first standard deviation, right? So this is one standard deviation. And the second rule, and second one is 95% of the data will fall under 2 standard deviation, right? So this is mu minus 2 sigma and this is mu plus 2 sigma, right? So this is 2 standard deviation. So 90% of your data, entire data will fall under this, right? You can see this is 2 standard deviation, right? So 95% data will fall under this 2 standard deviation. And the third rule is 99, right? 99.7% of the data will fall under 3 standard deviation. So this is 3 standard deviation. So right, 99.7% of the data will fall under this. So that's the normal distribution, right? So when you just try to have a data and if you just try to plot that data, if it is in the form of bell curve, then the data is normal. Then we used to call it as normal distribution. And if the data is normal, so these are the 3 rules we just have. We used to call this as empirical formula. Like we used to have this, and these rules will apply only if your data is normal. So yeah, you may ask, so what's the use? Like yeah, 68% of the data will fall under first normal standard deviation, and 95% in second standard deviation, 99.7% in the third standard deviation. So what's the use of that, right? You may ask. So from this we can able to remove the outliers, right? So we have understood that 99.7% of the data will fall under 3 standard deviation, right? So that's the rule we just have. When your data is normal, that's the rule which will be applicable. So using this, right? Using this, so for example, let's say you are just performing any kind of data analysis. So we just have a variable, let's take age variable, right? We just have this variable. Now, using that formula, you can able to remove the outliers. So you can just find the mu plus 3 sigma and as well as mu minus 3 sigma, right? You can find, like, if you have the data, right? If you have the data, and you can able to find the mu and as well as a sigma, and using that you can able to find the mu minus 3 sigma and mu plus 3 sigma. So now you can able to remove all the values which is greater than mu plus 3 sigma and which are less than mu minus 3 sigma, right? So if you have this distribution, so this is, let's take mu plus 3 sigma. Now the data which is greater than this, right, you can just able to remove this. So we used to consider that, so we can just consider that as outliers. And similarly mu minus 3 sigma, right, and the values which are less than this, we can able to consider that as outliers, and we can able to reduce the, so we can able to remove the outliers, right? So if we can remove the outliers, definitely it will be useful for our model, right? So if you have outliers in your data, definitely the model performance will decrease, right? So that's why using this normal distribution, using this you can able to remove the outliers. So and the last thing that I just want to mention you before ending this video is, so I will just draw 2 graphs here, 2 distributions. So let's take this as an assignment, like, or let's say let's take this and just try to mention in the comment section which is more normal, like which distribution is more normal, either the distribution 1 or let's say the distribution 2, which is more normal. So make sure to comment down below. This is a kind of simple exercise for you, so make sure to comment down below. So yeah, so with that, I hope this video is helpful for you, right? I hope you understood what is normal distribution. I hope you got what is empirical formula, like when the empirical formula will be applicable. So what's the use of this normal distribution, right? So we can able to remove the outliers, right? And also, yeah, that's the overall normal distribution. And in the further videos, we will just try to understand what is standard normal distribution, and also we will just try to perform different kind of tests, right, using this normal. So if your data is normal, we can do different kind of tests, right? The hypothesis test, like the Z test, chi-square, ANOVA. So this kind of test we can able to do when your data is normal. So yeah, we will just try to understand that in the further videos. So make sure to subscribe to the channel as well, and also like this video if you feel it's useful. So take care and thanks for watching.